Good morning and Jai Hind children. I welcome you all in today's live class of chemistry. Children, remember that in previous class I have started the chapter physical change and chemical change. Is it? And I have introduced also the meaning of the terms physical changes and chemical changes. So I hope that you understood the both physical change and chemical change. Now come to the next topic of the chapter. Is it? The next topic is given there as an activity in which simply we have to take a apple and cut a slice of apple. Okay, children, this activity is not required to do in activity notebook. So that is why I am not going to demonstrate it. I am just going to explain it. So in this activity, you have to cut a slice of apple and keep it exposed to air for some time. Is it? Now, do the same with a slice of brinjal also. Take a brinjal and cut it in pieces and expose them in air for some time. So after some time, does the color of the cut surface change? What do you observe? Is it changing? The change of color of cut surface is because of the formation of new substance due to the chemical reactions that occurs between air and the enzymes in the cut surface of apple and brinjal. Yes, the color gets changed because of a chemical reaction, and this reaction occurs between air and the enzymes. Children, enzymes are the chemical substances which are present in food items. Okay, so the reaction will occur between air and enzymes, and as a result, they will give a color. Change of color will observe there on cut surface of apple and brinjal. So this simple activity shows that the chemical change occur when a apple or brinjal is going to cut, and this chemical change occur because of the chemical reaction between air and the enzymes which are present in there. Okay, now after this we have an important topic of the chapter, that is rusting of iron. Children, you must have observed the rusting of iron, is it? You must have noticed that iron objects like iron nails or iron gates, they covered with a reddish brown substance. Okay, and this reddish brown substance is called rust. When iron is left exposed to moist air, it chemically reacts with oxygen and water, because in the air oxygen and water in form of vapors both are present. So the chemical reaction occurs between them and in the air to form a powdery substance that is called iron oxide. Okay, and in common language, common terms, we use the word rust for it. So the chemical name is iron oxide and the common name is rust. Okay, children? So the chemical reaction that takes place in rusting is when iron get reacts with oxygen and water. Okay, it forms a new substance that is iron oxide, Fe2O3 into that water H2, and the amount of water will depend on the water content present in air. Okay, so now balance it. Okay, children? Now the chemical reaction gets balanced. We can write here the four atoms of iron, okay, in left side, and four atoms of iron in right side also. Six oxygen and plus one, seven, and in next side right side six and plus 1 7, and hydrogen 2 atoms, and in right side also 2 atoms. So this is the balanced chemical equation, and this is the chemical reaction to show the rusting of iron. So when the rusting of iron occurs, this chemical reaction is going to occur there. Iron reacts with oxygen and water which is present in air and forms a new substance, and this new substance is known as iron oxide. Okay, and as you know that this one is iron, this is oxygen, and this is water. Okay children, so this is the chemical reaction of rusting of iron. Now the rusting occurs in the presence of both oxygen and water. As in chemical reaction, I have written that oxygen and water both. It means that they both are necessary for the process of rusting. The more humid the air, that faster the rusting occurs. Okay, if the humidity will be more, that water content in the air will be more, so the rate of rusting will increase, it will be faster, and the rust slowly eats away or corrodes the iron, leading to considerable loss. Is it? As you must have observed that after rusting, that the strength of that iron particle get reduced because that rusting is going to corrodes or damage the surface of iron article, and that is why the loss is occurred. For example, the rusting of ship is a major problem in the shipping industry because as the body of a ship is always in contact with water and the air around is also very humid, so the salt in water speeds up the process of rusting, and this leads to huge monetary losses to the shipping industry. Okay, so the shipping industry is going to be a great loss every year just because of the rusting. Understood, children? Now, if this rusting is going to create a loss, so how we can prevent this rusting? So there is some method used. There are some methods used for prevention of rusting. So come to the prevention of rusting. Prevention of rusting. Children, rusting cannot be prevented by not allowing the iron to come in contact. If we want to prevent the iron article from rusting, so what we have to do? Yes, we not have to allow the iron to come in contact with moisture and air. And the simplest method is to coat the iron with oil. If we apply the oil on the surface of iron, so what will happen? The surface of iron will not come in contact of moisture and air, and as a result, rusting will not occur. We can apply the grease. We can also apply the paint. So while coating the iron articles with oil, grease, or paint, we can prevent the process of rusting. And however, if there is a crack in the coating, the rusting starts. If this coating is not proper, there is a crack. So at that place, at the place of crack, the process of rusting starts, and slowly it will occur to overall surface of iron. So a more efficient method is to coat the iron with another metal such as zinc or chromium. Okay, because applying oil, grease or paint is not sufficient because somewhere because of the presence of crack, the rusting can be continued. So it's better to use the another method in which we are going to apply a layer of another metal. Okay, and that metal may be the zinc or chromium because these metals does not get rust. And this process of depositing the layer of zinc or chromium on iron is known as galvanization. Is it, children? So the process known as galvanization, which is used to prevent rust. Okay, and some more methods that are applying oil, grease, paint. Okay, now the water pipes you must have seen, which are used in our homes, they are made of galvanized iron. That is why they not get rusted easily, and that is why they look shiny. It means that the surface of the iron pipes get coated with zinc. Okay, and the method is known as galvanization, and such iron is known as galvanized iron, who have the layer of zinc. Understood, children? The prevention of rusting. Okay, very good. Now, after that, there are some oral questions given in the chapter. So, come to those oral questions. And the question number one, in which of these do the molecules of substances undergo changes? Physical change or chemical change? So, children, please remember that. Out of physical and chemical change, the molecules of substance undergo change. Here it's given the molecule changes. Okay, so the molecule only change in chemical changes. That is why the new substance form. If molecule will not go under change, so no new substance will form, and such change will consider as physical change. So here you can write that in chemical changes, the molecules of substances undergo changes. Okay. Now the question number two is, what kind of change does this represent? And it's given here in the question. Reactants are going to form products. So, in which change this happened? This happened only in chemical change, because the reactants are the original substances, and after a chemical reaction, they are going to form the new substance that are products. So, in physical changes, such change of reactants to products not occur, and this occur only in chemical change. Okay. Now, the question number three, what kind of change is the first melting of wax? Melting of wax. Children, when the wax melt, only their state change from solid to liquid. Okay, their chemical properties not change, and no new substance formed. So we can say that the melting of wax is a physical change. Yes. And the second one is given burning of wax. So when the wax burning candles, while burning it produces the new substance like heat, light, okay, and the vapors also. So they have the different chemical properties. So we can say that the burning of wax is a chemical change. Understood, children? So these are the oral questions which are given in your book, and you need to do it in your notebook also. Okay, now come to the next topic of the chapter, and the next topic is given that the characteristics of chemical reactions, a chemical change. When the chemical change occurs, a chemical reactions takes place. So what are the different characteristics of such changes? So we will discuss one by one about the characteristics. Okay, so come to the first characteristics of chemical reaction. Characteristics of chemical reactions. And the first characteristic is evolution of a gas. Evolution of a gas. Yes, children. A gas may evolve during a chemical reaction. If one of the reactants is a liquid or in solution form, so the evolution of gas is confirmed by appearance of effervescence, that is bubbling. Effervescence means bubbling in the liquid. Okay, so in the form of bubbles in that liquid, a gas will come, and this will confirm that some gases are going to occur produced there due to the chemical change, and the gas can be identified by testing it. And which gas is going to come out, we can test it. Okay, because the different gases have the different chemical properties. In a chemical equation, the evolution of a gas is shown by putting an arrow which pointing upwards, and when the same we are going to write in the form of chemical equation, so we will represent the coming gas by using the upward arrow. Okay, just like if I'm going to say that oxygen gas is going to produce in a chemical change, so we can write it like this. Okay, and when the calcium carbonate reacts with dilute hydrochloric acid, an example, when this calcium carbonate, children, the formula of calcium carbonate is CaCO3. Yes, when this calcium carbonate is going to react with hydrochloric acid, HCl, formula of hydrochloric acid. So it's going to produce the new products, that is calcium chloride, ACl2. It will also form water and a gas will produce, and that gas is carbon dioxide. So we will represent it by upward arrow. Okay, so this indicates that the carbon dioxide is going to produce in form of gas during this chemical reaction. Okay, this time this chemical equation is not balanced, children. Okay, so we can balance it as counting the number of atoms in left side and right hand side. Okay, now the equation gets balanced because the number of atoms of all elements are equal in left hand side and right hand side. Okay, now take another example. When the zinc reacts with dilute sulfuric acid, so it will produce the hydrogen gas, and the gas can be tested with the help of burning matchstick. Okay, children, when the burning matchstick is taken near the test tube containing hydrogen gas, the hydrogen burns with a pop sound, and we can write the equation as symbol of zinc is Zn. When zinc is going to react with hydrochloric acid, H2SO4. So it's form a new substance, that is zinc sulfate, ZnSO4, and produce a gas, that is hydrogen gas, and we show them by upward arrow. Okay, children, and here it's given also that how we can test the coming gas is the hydrogen gas. So the very simple, we can bring a burning matchstick near the mouth of test tube from where the gas is coming. If it will be hydrogen gas, so a pop sound will produce at the mouth of test tube. That will indicate that the coming gas is hydrogen gas. And if this pop sound will not produce, it means that the coming gas is not the hydrogen gas. So during this chemical reaction, a pop sound will produce that will show that the hydrogen gas is going to produce. Okay, one more example is given that when sodium nitrate is strongly heated at high temperature, so the oxygen gas is given off, And the presence of oxygen can be proved by bringing a glowing splint near it, and the splint burst into flame. Okay, and the chemical reaction will be that sodium nitrate, and the formula of sodium nitrate is NaNO3. When it gets heated strongly, it forms sodium nitrite, NaNO2, and produce oxygen gas. And we can balance it. Now the equation gets balanced. As this oxygen gas is going to produce during this chemical reaction, so how we can check it? So a very simple method is there. Bring a splint. Okay, children. Splint means when we going to burn a burning matchstick and off its flame. So we have a glowing splint. So when we bring this glowing splint near the mouth of test tube, what will happen? It will burst into flame. Again, the flame will produce from that splint. So this indicates that the coming gas is oxygen gas. Okay. So we can check the hydrogen gas, oxygen gas by different methods in different chemical reactions. Okay. So the gas is going to evolve, and this is one of the characteristics of chemical change. Understood, children, the first characteristic? Okay, I hope that you understood. Now come to the second characteristic of chemical change, and that is change of color. Change of color. Okay, one of the product formed during a chemical reaction may have a different color, and then that of the reactants. So the change in the color of product from the reactant also shows that chemical change. And in such a case, the change of color accompanies the chemical reaction. If the color is not going to change, so we can say that chemical reaction or chemical change is not going to occur. Okay, there are certain examples like the first one, when green colored copper carbonate is heated strongly, so a black residue of copper oxide is left. So this change in color indicates that yes, the chemical change. So the reaction we can write as when green colored copper carbonate. The formula is CuCO3. It is green color. And when this copper carbonate get heated strongly at high temperature, so it form a blackish residue, and that is copper oxide, which is black in color, and plus give out the carbon dioxide gas. Okay, children? So the carbon dioxide gas is going to show by arrow, and the product, which is black in color, that is completely different from the reactant, because reactant is green in color and product is black. So we can say that here chemical change is going to occur. Okay. Now the second example is when white crystal of lead nitrate are heated strongly, so it will form the yellow colored lead monoxide, and a reddish brown gas, that is nitrogen dioxide, is also given off. Okay, so here again the change of color is going to observe, and the chemical reaction will be that the compound is lead nitrate, and the formula will be PbNO3 whole twice. The formula of lead nitrate is PbNO3 whole twice, and this, when heated strongly, it forms lead monoxide. PbO, and also form the gas that is nitrogen dioxide and also oxygen. So these two gases are going to produce it. Now balance this chemical equation, okay, because this time it is not balanced. Okay children, now the question gets balanced here. The lead nitrate, it is white in color. Okay, and after the chemical reaction, the new substance which form lead monoxide, it is yellow in color, and the gas will release that is reddish brown. Okay, so this indicates that the chemical change is going to occur here. Okay, because the characteristic shows that the change in color is observed in these chemical reactions. Either the first one, copper carbonate, which is found in green color, and after the reaction of black color residue, that is copper oxide formed and carbon dioxide gas released. Either the second example, lead nitrate, which is white in color, and after the chemical reaction that strongly heated, the new product is going to form, that is lead monoxide, which is completely different in color. The lead nitrate is white in color, whereas the lead monoxide is yellow in color. Okay, and along with this, a gas is going to form, which is also having the different color, that is reddish brown in color, and this gas is nitrogen dioxide, and along with that one more gas which is colorless, that is oxygen, is going to produce during this chemical reaction. Understood children? So the characteristics of chemical reactions are: the first one, evolution of gas. Some gases will evolve like carbon dioxide, hydrogen, nitrogen, oxygen, etc. That indicates the occurrence of chemical reaction. And we can check the presence of these gases, like the hydrogen can be checked by bringing a burning matchstick near the mouth of test tube, and it will produce a pop sound. So that indicate the hydrogen gas. And for oxygen gas, if the yes, a splint comes near the mouth of test tube, it bursts with a flame. Again, the flame will start. So that will indicate the occurrence of yes, oxygen gas. Okay, and the carbon dioxide gas that extinguish the flame when the bringing that burning matchstick comes near the mouth of test tube from which carbon dioxide gas is coming, so the flame will goes off. That indicates the carbon dioxide gas is going to produce. So these all are going to indicate that the chemical reaction is going to occur, and due to that the gases are going to evolve. Okay, and in second characteristic of chemical reaction, that change of color, the reactants will have the different color and the product will have the different color. Okay, that also indicates the occurrence of chemical reactions. Okay children, there are more characteristics of chemical reaction, so we will discuss the rest of the characteristics in next class. Okay children, so I hope that you understood these two characteristics. Thank you and have a nice day.